At this point in the module, I have introduced you to the idea of velocity. The velocity of an object is the rate at which the position of the object changes. And we have done some example problems involving objects moving at constant velocity. Now we're going to consider an object which clearly is not moving with a constant velocity. So look at the car in the figure here. The car is moving along the x-axis, and the position of the car has been indicated at 1 second intervals. So at time 0 seconds, the position of the car is 0 meters. At time 1 second, 1 meters. Time 2 seconds, 4 meters. Time 3 seconds, 9 meters. And time 4 seconds, 60 meters. You can see that the car experiences a different change in position in each of the 1 second intervals. And because the car's position changes by different amounts in equal time intervals, then clearly the car is not moving with a constant velocity. And in particular, it looks like the general trend here is that the speed of the object is increasing because in each of the 1 second intervals, the car's position changes more than it did in the previous 1 second interval. Now, in class, we're going to do an exercise which will give us approximate velocities for each of the moments depicted in the figure. For now, I'm just going to give you the results of that exercise. So at time 0 seconds, it turns out that the velocity of the car will be about 0. So this is when it starts moving. At time 1 second, it will turn out that the velocity is about 2 meters per second. At time 2 seconds, about 4 meters per second. Time 3 seconds, 6 meters per second. And at time 4 seconds, 8 meters per second. What I'd like you to try and do here is to examine the figure and see if you can come up with a way in words to describe what's going on in the figure. Some of you may know where this is going, and you may be thinking of a certain word that starts with the letter A. So for now, put that out of your mind. See if you can describe what is going on in the figure using only terms that have already been introduced in class, namely time, position, and velocity. So try that on your own. So pause the video, try that on your own, and then rejoin the video. All right, so one way we can describe what's happening in the figure here is that for every 1 second interval, the velocity of the car changes by 2 meters per second. In the first 1 second interval, the velocity increased from 0 to 2 meters per second. In the next 1 second interval after that, the velocity increased from 2 meters per second to 4 meters per second, and so forth. So for every second that goes by, the velocity increased by 2 meters per second. So let me write that out. So every second, the velocity increases by 2 meters per second. Let's put that a different way. Let's say that the velocity changes at a rate of 2 meters per second per second. Now, if the velocity changes at a rate of 2 meters per second, could we also say that the velocity changes at a rate of 2 meters per second squared? Okay, so far we have seen that the velocity of an object can change at a particular rate. And for this car in this scenario, that rate is 2 meters per second, or 2 meters per second squared. Let's give a name to the rate at which the velocity changes. Let's call that the acceleration. So the acceleration, the symbol is A, is the rate at which an object's velocity changes. Or we can say that the acceleration is the amount of velocity change per time. For the car in the example here, we can just say that the acceleration of this car is 2 meters per second, or 2 meters per second squared. Now we're going to do an exercise, which I hope will help you develop your understanding of the acceleration. So I've drawn out a scenario here where the velocity of a car is indicated at 1 second intervals. So at time 0 seconds, the velocity is 0 miles per hour. So this is where the car starts to move. At time 1 second, 10 miles per hour. At time 2 seconds, 20 miles per hour. At time 3 seconds, 30 miles per hour. At time 4 seconds, 50 miles per hour. And at time 5 seconds, 70 miles per hour. So I'd like you to pause the video, and while the video is paused, see if you can use the idea of acceleration to describe what is going on here. So what is the acceleration of the car at the different points in the motion, right? And then when you think you've given it a good shot, then you can rejoin the video. Okay, so here's how I would describe what's happening. In the first 3 seconds of motion, the velocity increases by 10 miles per hour for every 1 second interval. So since the acceleration is the amount of velocity change per time, and the velocity changes by 10 miles per hour every second, I would say that here the acceleration is 10 miles per hour per second. In the last 2 seconds of motion, the velocity changes by 20 miles per hour in each 1 second interval. So in the last 2 seconds of motion, I would say that the acceleration is 20 miles per hour per second. So in this video, we have explored the idea that the acceleration is the amount of velocity change per time, but we have not discussed the direction of the acceleration and when do we say that the acceleration is positive or negative. So in the next video, we're going to discuss the direction of the acceleration and when do we say the acceleration is positive and when do we say the acceleration is negative.